Good morning, everyone. Shall we start? Have you all done yesterday's programs which I've sent you? Those are very small and simple automata questions. I want the interaction, please. Oh, done. Okay, ma. Chalo then. Today we are going to see arrays and functions so that it will be very easy for us to understand all the automata questions. Okay. So first, what I do is I'll start with the arrays topic, the syntaxes, and how array, 2D array and pointers, 1D array, how they are related with the arrays, how they are related with the pointers. Then I'll go with the functions, how different kinds of functions will be written using a pointers and with arrays also. Okay, chalo, shall we start? So first, why we have an array? Why we have an array? This thing we have already done. Okay, but once again it's very important for me to tell you all these things so that it is very clear for you. Okay, with a little extension on the first day's class. Yeah, to store homogeneous element. Okay, that's a very good definition, but still I just want to change the definition of arrays. So let us see how the definition has to be done exactly. Okay, so first, why do we have a variable? I told you on first day, why do we have a variable? Variable has come into the picture. Why? Why? Because as I have requested over here, I just want to have 2 bytes of memory. It's an operating system's duty to allocate me a memory, right? To allocate a memory for me, it's an operating system's duty to allocate a memory for me. After allocating, which 2 bytes of memory has been allocated, as an acknowledgement, operating system will give me the first byte address. To remember this first byte address, humans cannot do that, and we cannot do that. We cannot remember this particular ID, 16-bit ID. That is the reason we have variable over here, right? Then in that particular location, from this particular address, 2 bytes, in these 2 bytes we are storing 320 like this in a binary format. Okay, then if it all we write like this, address of a and a, it is going to give you address of a and a's value, what is being stored inside this. Okay, you may have a doubt, why A is storing only the first byte's address? Why not the second one? Why not the second one? Because it's a continuous memory location. It's a continuous memory, right? So if you know the first one, if you know the from here, how many bytes? 2 bytes. That means, is there any requirement of having storing this particular second address also? Not required, no. So that's the reason we are going to, operating system gives us only 1 byte, only the first byte's address. Okay. If at all you request 1000 bytes also, continuously 1000 bytes will get allocated, but from the operating system will get only the first byte's address. Okay, because it's a continuous memory. Okay, understood why only the one address we have got, only one address we got, we are not capturing the second address. Okay, operating system gives us only the first byte's address. It won't give you. Okay, fine. Okay, chalo. Is this clear for you? This particular picture is clear for you? I hope it's done, because on the first day also we have seen the same thing. Okay, then we are going to store two kinds of things will be stored in the memory. One is data. Data is nothing but numbers, characters, floating kind of thing, are nothing but the data. And one more thing we can store is we can store the address also. This is remembering. Storing and remembering is quite different in the computers. Okay, for us storing and remembering is same, but coming to computers, storing and remembering is quite different. This A duty is to remember the base address. This in a Java we call it as what do you say? Objects ID. Okay, objects ID or address. Okay. Then now we are trying to store. Let me go with the second slide. Here I have this. When I write int A, 2 bytes of memory got allocated and the base address is 2x1 which is being stored by A. Okay. Then in the second line I have written star B. What is star means? Star means we have two kinds of variables, data variable and pointer variable. Data variable will able to store only the data. Pointer variable can able to store only the address. Address variable can able to store only address. It cannot store data, and address variable cannot store address. Address variable can store only address. Data variable can store only data. Okay. So now in this particular A, I want to store a data. This is called data variable. Okay. Then we have a star. Star indicates that it's an address variable. I am going to store address of some other memory location. Okay, address of some other memory location. I don't know what is there in that also. I just want to store the address of some other memory location. That's it. Okay. Then whenever this star is seen by the compiler, it understands and tells the operating system operating system allocates us the memory of 2 bytes. Why only 2 bytes? Did we mention int over here? We did not mention. Then also it is allocating only 2 bytes. I told you I am considering a 16-bit operating system. If you consider a 16-bit operating system, then 2 bytes of memory will be allocated for us. 2 bytes of memory will be allocated for us. Okay. And for this 2 bytes also, one base address will be there now. In order to remember this base address, we are using a variable B. Okay, we are using a variable B in order to store the base address of this particular location. Is it okay? That is the reason B is a variable or identifier. Okay, A is also a variable or identifier. Okay, is that okay, guys? Now, what do you call this particular variable? This is called data variable. This is called address variable. B is an address variable. A is a data variable. Okay, this is how memories got allocated whenever you write this. Okay, now the problem comes over here. Now, if at all I have written like this, A is equal to 320, then what happens? Immediately 2 bytes of memory will get allocated and 2x1 will be remembered by A, and inside that we are going to store 320. This is correct. Then whenever we say star B, 2 bytes of memory will get allocated and 3x1 is the base address being remembered by B, and inside this location we are storing 2x1. That is the address of A. Okay. Then I have written a printf statement over here. I have written here. What is A? What do you have inside A? What is the data present inside A's location? That is 320. A's location is 320. Then what is address of A? Address of A is 2x1 because we know it only gives the one address, not the two addresses. Okay, base address will be given. Then what is address of B? Address of B is 3x1. Then what do you have inside B? Inside B you have 2x1. That is also fine. Then comes star. Here we have written star B. Star B, star in the sense this is called declaration part, where which is used for declaring or how much of memory is being allocated. The declaration part is being done over here. How much of memory has to be allocated, and memory allocation will be done over here. Okay. But coming to the usage, this is the usage. Okay. Here the star is referred or read as what? Read as what? I told you on the first day. What star is read as? Read the value from the given address. Okay, the star, you are going to read like this. You're going to read star as only star. Read the value from B. What do you have inside B? 2x1. Read the value from 2x. Read the value. Go and read the value from 2x1. Okay, I'm going and reading value. Value presented B is 2x1. Okay, I'm going to 2x1 and trying to read the value. But should I read only 2x1 or else 2x1 and 2x2? That is actually a dilemma or ambiguity for the compiler also. Okay, then what does the compiler do is it will go and search what you have in front of this. What is the data type written in front of this? Okay, did we write any data type? If at all we don't write any data type, it will give you error. You did not mention how many bytes has to be accessed from the given address. How many bytes has to be accessed from the given address has not been mentioned. Okay. So now here I'll mention char first. This part I have explained the same. I have taken the same slide also. I am explaining once again. Here, this part I am writing. I have written once again over here. I said star b in the sense go and read the value from 2x1. Okay, I'm going and read. I'm trying to read, but how many bytes we have to read, I don't know. So I'll just go and see the access right. What do you have in front of the star b? I have cat in the sense 1 byte. Go and read only 1 byte. Okay, go and read only 1 byte. What do you have in that 1 byte? In the 1 byte you have 64. So the answer is 64 over here. The answer is 64 over here. Okay. That is the reason in front of a pointer variable we call this data type as access right. How many bytes has to be accessed? Access right. Okay. Then if at all I write over here int, then from the given address to x1, go and read from to x1, go and read 2 bytes. So if we read completely 2 bytes, first byte is this, second byte is this. If you completely go and read 2 bytes, then you will get the answer as 320. Okay. Then if at all you write float, then what happens? Go and read from 2x1. From 2x1, how many bytes we are going to read? 4 bytes. That is 2x1, 2x2, 2x3 and 2x4. Do we know what is present in 2x3 and 2x4? We did not write anything. And that might be used by the operating system itself. We don't know, right? So by default, we'll get a garbage value. But here, it depends upon your compiler. Sometimes it will show you garbage value, sometimes it will show you error. Okay. Now here I'll consider as garbage value. According to theory part, I'll consider it as garbage value. Is it okay, guys? We are reading 4 bytes from 2x1. From 2x1, 4 bytes has to be read. First byte, second byte, third byte, and fourth byte. Okay. So that is the reason in front of a pointer variable, whatever you write, that is considered to be a access right. That is considered or treated as access right. Is it okay, guys? Shall we go further? Then comes here. Then I told you that here in this I am trying to explain you what is a pointer incrementation. What do you mean pointer incrementation? I just want to tell you what is pointer incrementation. This is data variable. This is pointer variable. A is a data variable. B is a pointer variable. Now A in the sense it's not address. A in the sense it is 320. 320 plus 1 is equal to 321. So in the memory location the data will get stored like this. In the memory location the data will get stored like this. Okay. This was previous one. Now it has been changed like this. Then whenever I say B is equal to B plus 1, what do you mean by B plus 1? B is equal to 2x1. It's an address. It's not data. It's an address. Can we increment the address? Actually, we cannot increment the address because address will be given by the operating system. We cannot touch the address also, right? We can just move from that particular place to next location, or we move forward and backward. That's it. But we can't change the address, right? So now I said plus 1. Plus 1 means move forward. Plus in the sense move forward. Okay. By how many steps you are going moving forward? Only one step, only one location you have to move forward. Okay. That location where you're going to move, like how many steps you're going to take from that location. Go and see the data type written in front of it. If at all I say char in the sense 1 byte. From 2x1 take only 1 byte. Next immediate. That means it will go and move to the 2x2. If at all I say char, it will move to 2x2. Is that okay? If at all it is char. If at all I change this to int, then I'm going to move only one step, but where should be my next step? Right now I'm at 2x1. I need to make only one step. Where that step has to be stored? Yes, correct. It is 2x3. Okay, it is 2x3. Correct. 2x3. So that is the reason we have a formula for incrementation. The incrementation formula is from the base address, how many steps you want to move into the data type written in front of the pointer variable. Okay, this is the formula. This one is the formula. The formula is address, first base address, yes, okay, the spelling is wrong. Base address plus number of steps into data type is the formula for finding where must be my next step has to go. Okay, this is a formula. Done. Then comes, let us go with this. I have to store 10, 15, 20, 25 and 30. In order to store 10, I require 2 bytes of memory. Then for this 2 bytes of memory, one base address will be there. In order to remember base address, I require a variable. Again, to store 15, again I require 2 bytes of memory. Then for this 2 bytes also, one base address will be there. In order to remember the base address, we require some variable called b, like this. One variable we want. Yes or no? One variable we want. Similar way, for in order to store 20 also we have 2 bytes. We need 2 bytes of memory, and in order to remember the base address of those 2 bytes, we require a variable. In such a way, how many variables do we require to store these 5 numbers? 5 variables, right? But now the problem is, for 5 it's okay, we can remember ABCD. But if you have some 50 numbers, some 10 numbers also, what happens at that time? 10 variables you have to manage every time. In order to do the sum also, what we need to write? A plus B plus C plus, there's a 100% chance that I can write wrong variables. Yes or no? Okay, that means we need to remember the variables every time, right? So that's a problem. In the variables we have this problem. That is the reason what we have done is, not we, the one who have developed this programming language, what they have thought is, anyways you want 2 bytes of memory, no? Then why don't we store them in a continuous manner, like this, in a continuous way? You anyways do want 2 bytes only, but don't store in a random locations like this. X1 is one location, F21 is one location, GY1 is one location, GV01 is one address. This is being randomly stored in some like different 2 bytes of memory locations. Okay, so we are storing those 2 bytes in a continuous way like this. Okay, continuous way. Now in this particular if at all you have a continuous memory allocation, then what happens? We require only one variable to store the base address. From here it's a continuous, right? So if at all it is continuous, we need to have only one variable to remember this base address, right? So that is how we have achieved something called reducing the variables by using arrays concept. We have done reducing of variables by using the arrays concept. Okay, then how to now what is an array? If at all you ask me what is an array, I would have tell the answer like this. Array is nothing but a continuous and fixed memory, which is being sliced equally. That is called homogeneously, which is being sliced equally. This is an array definition. Okay, what is an array? Array is nothing but a continuous memory, continuous and fixed memory. Okay, which is being sliced equally, 5 equal parts. See, 5 equal parts. Then then how do we write this? Whenever you have this particular brackets, that means it's a continuous memory. Whenever we have this particular angular brackets, that means continuous memory. Okay, then if at all you write I just wanted to have continuously 5 slots. Okay, you want 5 slots, but each slot is of how many bytes? Each slot is of 2 bytes. Okay, each slot is of 2 bytes. Then immediately operating system will allocate as a memory like this somewhere. Continuously 10 bytes of 5 into 2 is 10 bytes of memory will get allocated for us. And for this continuous location, this is the base address. This is the starting address. So this address has to be remembered by someone. Who is that someone? That someone is nothing but your A. A is a variable used for remembering the base address. Okay. Then we call this first location as A of 0. You might be knowing all these things. We call this as A of 0. Let me write here. Okay, this location is nothing but 0th index value. I told you why we have the 0th index also. Again, I'll repeat once again because today we are discussing complete syntax is also. This is referred as A of 1 location, A of 2 location, A of 3 location, and A of 4 location. A is nothing but the base address. A is nothing but the base address. Okay? Now let us go with this. I have written A of 5. That means 5 slots of memory has been allocated. Then, now my first question is, if at all you write like this, are you going to fill the data also? If you write only the first instruction, A of this one, if you write only the first instruction, if you write only this first instruction, this one, the first instruction, is it going to fill the data like this? No, it's not going to fill the data. Then what do you have inside that? What do you have inside these locations? Garbage values will be there. Okay? Garbage values will be there inside these locations. Okay? Then, how are you going to fill the data? By reading from the keyboard using a scanf statement, or else we can directly write like this. Here I have mentioned int A of 1, 2, 3, 4, 5. That means, did we mention here? I said array means continuous memory. Okay? Whenever you say brackets, that means continuous memory. If at all you don't write, if at all you don't specify anything, is it okay? Like for example, instead of writing 5, if at all I mentioned empty, is it okay? No, see, see here, I have in the first instruction I have written int A of empty square brackets. Now, does the compiler understands how many blocks you want? How many blocks you want? How many slots you want? Does the compiler understands? No, compiler won't understand. It is compulsory. It is compulsory to write some number inside this. Okay. Let me write over here 5 this time because I just want to store 5 elements. Okay. 5 or 50 depends upon you only. Then the compiler understands, okay, they want 5 blocks each of 2 bytes. Okay, 5 blocks each of 2 bytes. Done. Okay. After that, what happens is using a scanf statement. I'll write here itself. Using the scanf statement, I'm going to read some elements into it by writing scanf A of 0, A of 1 like that, or else I can mention A of I. What is I? I means my range of numbers. Yesterday in the for loops we have seen, whenever you want a continuous, whenever you want to have a sequential number, then we go for a for loops also, right? I is less than or equal to 4, less than or equal to 4, I plus plus. Okay? Whenever you write this, then what happens is compiler will allow you to read some data into the memory locations. Okay, now right now I'm reading 1, 2, 3, 4, 5. This is how we read the data. Okay, now this is how we read the data. Now I'm not talking about this. This is very clear, I hope. This particular part is very clear. Yeah, this is the basic one. Everyone might be knowing about this. Okay, now I'm removing this. Now I'll just talk about this one. Can I write int empty like empty slot and 1, 2, 3, 4, 5? Yes, we can write. Then how does the compiler know how many slots has to be, how many blocks has to be given? It will be taken by the num elements present over here. First one, in the first slot, it is going to fill 2 bytes 1, and 2 in the second slot, in the 3 in the third slot, 4 in the next slot, and 5 in the next slot. Okay, is that clear, guys? This is how the compiler fills the data if at all you write like this. But if at all you don't give the data here, if you don't give the data here, it's an error. It's an error. Okay? Then you might have one more doubt. You might have one more doubt. What if we give both? Yeah, this is actually a very good question if at all you have this. Do you have this question in your brain? Yes, guys. I want you to interact with me. You have this question, what happens if, okay, I'll ask you, what happens if at all you write like this, A of 100 and 1, 2, 3, 4, 5? What happens? Yes, what happens? Memory wastage, correct? Rest of all will be filled with zeros, correct? Yes. It allocates continuously. See, my question was, if at all you give empty, if at all you make this particular slot like indexes, like the number of slots is empty parentheses, if at all we give empty square brackets, if at all we give, what happens is continuously 5 slots will be allocated, as well the data also will get filled. Okay, then if at all we write over here some 10, then what happens? Then what happens is, what happens? Continuously okay, spelling is a mistake. Continuously 10 slots of memory will be created, 10 slots of memory will be allocated, as well in the first 5 slots data will also be filled, and in the first 5 slots data also will get filled, and in first 5 slots data will get filled. Okay, in the first 5 slots data will get filled, and rest of all will be zeros. Zeros are garbage values. It depends upon your compiler. If at all it is a global variable, all will be zeros. If it is a local variable, local array inside the memory location, then it will be garbage values. Garbage values means which we haven't kept. Garbage values can be valid numbers, or it can be any number. Okay, garbage values. Okay, done. Then actually this is actually a problem. In order to solve this problem, we have a concept called stacks. This is actually a problem. Okay, I'll tell you this particular problem when we discuss the data structures. Okay, now right now we write all the programs using this only. We are not giving any number on that. Number of slots we're not giving. We're just giving numbers directly. Okay, it's a problem which will be explained in 2 days. Okay, when I discuss the stack program. Okay, now what happens is, if at all I write only A, what happens if you write only A? What is the output of this particular line? Printf percentage A. 1x1? Yes, very good. 1x1. Base address 1x1. Then, what is address of A? That is also 1x1. Correct. What is address of A of 0? That is also 1x1. Correct. Then, what is A of 0 and what is A of 1? We are not talking about address. We are directly asking the data present in A of 0 and the data present in A of 1. What is the data present in A of 1, A of 0 and A of 1? That is 1 and 2. That is also correct. Yes, correct. Then, what is 1 of A? Can we write A of 1 as 1 of A? Yes, we can write. So here also the value is 2. Okay. Can we write this 1 of A as star A plus 1? Yes, this we can write like this. Why we can write like this? Why array index starts with 0? Because array. Okay, one more question I have over here. This is also correct. We can write like this. We can write A of 1 as star A plus 1. Okay, we can write like this. Now I have one question for you. Did I mention this A as a pointer variable? Is it a pointer variable? Why it is giving us the address? Why it is giving us the address? Is it a pointer variable or data variable? It's a data variable. Then why it is giving us the address? Because whenever you write this particular square brackets, it converts itself into a pointer variable, internal pointer variable. Okay, now A is a internal pointer variable. Okay, every array variable acts like a pointer variable. Okay, then why array index has to start with 0? That is the next question. The answer for that is, if at all we write star A. Okay, I'll write A of 0. A of 0. A of 0 value is what? 1. Right now it is 1 actually. Okay, I told you we can write A of 0 as, we can write A of 0 as 0 of A also. As well, we can write this as star A plus 0 also, right? Star A plus 0 also, and something plus 0 is 0, something only, no? So I can write this as only star A. Yes or no? As just now we made one point, that is array variable acts like a pointer variable. Okay, in order to justify that particular statement, I am telling you this one. Okay, and that is the reason the offset has to always start with 0. That is the reason offset has to start with 0. Okay, then what is star a? Star means what? Read the value presented. What is x? A. What is a? A is nothing but 1x1. What is the value presented 1x1? That is 1. So that is the reason here it is 1. You got the correct answer as it is 1. Okay. Is it clear? Just now we have seen pointer incrementation also. Let me write over here. Let me change. Let me make out these things. Let me take out these things. And let me write over here a plus 1. Okay. What is a? A is nothing but 1x1, 1x1 plus 1. What is 1x1 plus 1? What happens whenever you write 1x1 plus 1? 1x1 is the address. Plus means move forward. Move forward and take one step. Okay, taking one step. But how many bytes should I move? I have go and see the data type written in front of it is 2 bytes. That means the formula will become into data type. What is the data type? Int. That is 2 bytes. So your address will be value presented 1x3. Yes or no? What's the value presented 1x3? And from 1x3, how many bytes has to be read? Go and see the data type in front of it. 2 bytes. So 1x3 and 1x4 has to be read. And what is the value present in that particular place? Yes, correct, guys. What's the value present at 1x3? That is 2. Okay, that is how a pointer increment works. That is the reason I told you the pointer incrementation. Okay, now just see this question, the other side. Now, anyways, this A is also an address, right? I'm taking a pointer, additional pointer along with this statement. I'm writing one more additional statements here. I have taken int star p. That means a pointer variable which can able to access 2 bytes every time. A pointer variable which can able to access 2 bytes every time. Okay. Then I'm allocating a value. A in the sense address only, no. Here A is nothing but address only, no. That address I'm allocating to p. Now P contains. Now what is the P contains? What does the P contains after this instruction? Okay, initially I'll write null so that it will be clear for us. Clear in the sense now I'm making it as null pointer. Yeah, what's your doubt, ma? Yeah, anyone have doubt? Okay, first I made as null pointer. Why did I make this as null pointer? Because initially it has a garbage value inside that particular location. I just don't want that. Okay, so that's the reason I made it as a null pointer. I'm initializing. I'm making everything as null inside that particular location. Okay, then I'm writing over here printf. What is the value? What is the value present inside your p? That is 1x1. Correct. We write here as address of a. That is 1x1. Okay, then what is address of p? What is address of p? Address of p is 1? No. What is address of p? No. Wrong. What is p actually? It's a pointer variable, no? So whenever we write a pointer variable, what happens immediately? 2 bytes of memory will get created. Yeah, 2 bytes of memory will get created. Two bytes of memory will get created. Very difficult to draw. Okay, 2 bytes of memory got created here. Okay, for P, 2 bytes of memory got created. For this also some address will be there, like some address will be there. Let me write the address as 000. The address as 0x. And this continuous memory, no, this address I'll write as 0x1. Okay, two continuous bytes. Okay. 2 continuous bytes. Then what is the address of P? The base address among these two. The base address is x0x. So the base address is 0x for P. What is the value present at P of 0? P means what? P means what? We can write this as, we can assume this as what? We can assume this as star P plus 0. Yes or no? P of 0 can be treated like this. Star P plus 0. What you have inside P? Inside P you have 1x1. So this can be replaced as 1x1 plus 0. That means don't take any step. Okay, I'm not taking any step. Then what's the value presented to star 1x1? The value presented 1x1 is 1. Okay, that is how you need to understand. Now, do you find any change in the output even though you write this or this? The both are same. Okay. These two programs are same now. Yes. Okay. Yes. We already said P is equal to A. That means we are allocating the address. Yeah, 16 bits address. Okay, I got some answer like 2x1. What is this 2x1, Pravalika? Why 2x1? And Priya, what is 2? Pointer incrementation means moving forward, that's it. Moving forward by 0 steps. That means stay there only. Okay. We are allocating A's value. A is nothing but pointer bytes. Okay. Pointer is a variable which can able to store the address. Its capability. This star represents its capability. It can able to hold the address. That's it. Okay. It is not a data variable. It's a pointer variable. It has to store the address. Inside this, we are storing the address of 1x1. So inside this, we are going to store 1x1. 1x1 will be stored inside this. Okay. 1x1 will be stored inside this. You have any doubts still here? If you have no doubts in this particular area, then we will go for the 2D arrays. It depends upon your again operating system. We have two types of operating systems. Okay. So sometimes we refer from right to left and sometimes we refer from left to right. It depends upon operating system. Right now, as for me, writing the numbers from here to here is easy. That's the reason I wrote like this. Little Indian and big Indian, we say. It depends upon operating system. 48, is that clear for you? Memory allocation depends upon your operating system. Okay, it doesn't depend upon us. For writing sake, for me, it was easy. That's the reason I have written like this. Percentile D, actually percentile D means it represents a number. But if at all you want the correct address, you have to go with P. If you want correct address, you have to go with P. But right now I understand the numbers easily. That's the reason I have written over here D. Okay. Then coming to this particular second printf statement. Okay, explain the pointer incrementation of particular one. Okay, done. I'll do that. I'll explain the pointer incrementation once again because it's really very important. Okay, I'll tell you once again. See, first my instruction is this: int a of empty. Empty in the sense I don't know how many slots are there. Based upon the assignment of my numbers, you please allocate the memory. That is a request being given by the programmer to the operating system. Done. Memory is being allocated according to the assignment of the numbers. Done. After that, when you write like this, what happens is immediately operating system will allocate and give the 1x1 as the acknowledgement to A. Now A's duty is to remember the acknowledgement address 1x1. That is it clear? 1x1 is remembered by A now. Okay. Then I'm coming to the pointer side. Then I said star P. If at all I write only star P, then immediately what happens is 2 bytes of memory will get allocated for us. Why 2 bytes? Because I'm considering a 16-bit address 16-bit operating system. So for every memory byte, 16-bit address will be there. 16-bit address. Here I wrote only 3 bits, but 16-bit address will be there. In order to store 16-bit address, I want 16 bits of memory locations. That means 2 bytes. 2 bytes got allocated for the start P. Okay. Then after allocation, now P remembers 0x. 0x is I'll write 0x0. 0x0 is the base address of this location. 0x0 is the base address of this particular 2 bytes location. 0x0 is the base address of this location, which will be remembered by your P. P remembers P. P's duty is to remember the base address, that is 0x0. Is that clear, guys? Then comes P is equal A value. What is A? A is remembering 1x1. That has to be stored inside this P. Okay, 1x1 has also been stored. Done. Then I'm asking, what is there inside P? Inside P location, what do you have? Inside P location, what do you have? 1x1. Okay, 1x1 has been written. Okay. Now I'm asking, what is the address of P? What is the address of P? Address of P is 0x0. Is this clear, guys? Address of P is 0x0. Inside this P, what is being stored? 1x1 is being stored. Okay, ma'am? Is it clear? Okay. Then comes pointer incrementation. I'll explain within a while. Within 1 second, I'll explain. Okay. Then comes, I have written over here. See, I'll write here. Okay, let me make my numbers like this. I'll see. I know the 320 binary format very well because I usually write that. That's the reason I know the 320 binary format. So I'll write 320 here. 320 binary format is 10160s. 10160. So I'll write like this. First we'll start with zeros only. 0, 0, 0, 5, 6, 7 and 1. This is first byte. Second byte is 0, 1, 0, 0, 0, 6, 7, 8. Okay, 10160. This is 320's binary format. Right now we are talking, this is 1x1 address, this is 1x2. See, I'm writing this one. This 320 is being stored. That means 1x1, 1x2 is this now. Okay, guys? Now let me tell you this. Pointer incrementation. Let me write over here char. For a while, let me write over here char. Yeah, here if you write float also, it will work well. Now, right now, I have written char. Okay? And then I have written over here P of 1. P of 1. P of 1 means this also can be written as what? P of 1 can also be written as star P plus 1. Yes? Yes? Am I correct? Yes, we can write like this. Now then what I do is I'll simply write this star as again star will be like that. P is nothing but what do you have inside P? 1x1. 1x1 plus 1. I have written 1x1 plus 1. Okay? Okay. What is 1x1? 1x1 is the address. I am staying at right now I'm at 1x1. Okay? I have to take one step. Done. Where this step has to go and see the data type written in front of it. I am taking only one step. Data type is 1, right? Data type is char. Char means 1. Char means 1 byte. So it will result us to which place? Star will be like that. You will be going to the next location, that is 1x2. Okay? Now, what is the value present at 1x2? What's the value present at 1x2? What's the value present at 1x2? Please tell me. What's the value present at 1x2? You see only 1x2 location. It's no, wrong. Only 1x2. 1x1 and 1x2 combined gives you 320. But I'm talking only about right now, only about 1x2. That is 1. Yeah, it is 0, 0, 0, 0, 1. So it is 1. 2 power 0 is 1. Okay? Understood? Okay, let me give you one more example over here itself. Okay, let us consider now my p value. My new p value. P is equal to p plus 1 I have written. P is equal to p plus 1 I have written. So my p value got changed to 1x2. Why 1x2? Because I said increment means go and see the data type. It's plus 1. So it is 1x2. Right now my p value has changed to 1x2. Okay. Then again I'll do incrementation. P is equal to p plus 1. What happens to my p? What happens to my p? Right let me know. Right now my p value is 1x2, 1x2 plus 1 into data type. Data type is char. Char means 1 byte. So char means 1 byte. So I'll replace that. So I'll just write 1x3. So what is the value present at 1x3? What is the value present? Oh, if at all I keep a star here also. I just want to write star also. I'll write star. Star 1x3. That means value present at 1x3. What's the value present at 1x3? Star means read the value from 1x3. What is the value present at 1x3? What's the value present at 1x3? That is 2. Right? That is 2. Let me again increment. Let me again do incrementation. Let us do one more time incrementation. I'll write 2 steps. I'm going to make 2 steps. That means I have to move to which place? 1x2 plus 2 into 1 will move to 1x4. Am I confusing you people? Is it really going difficult way? I'm at 1x4 right now. What is the value present at 1x4? Yes, it's 0. Oh, Priya, should I? Yes, it's correct. 0. It's not 2, it's 0. 1x2 contain 1x4. Only in 1x4 location, what do you have? Yes. Okay, I'll explain this particular thing once again because even for the 2D arrays, we want a pointer incrementations only. Okay, I'll take this slide once again. I'll just copy this so that it will be clear for me. I'll just copy this slide. Okay, I'll make changes here. See, I'm writing in this textbook. I'll write int. This time I'm writing int star p is equal to a. That is address of a is being allocated. Okay, address of a is 1x1 being allocated in p. Okay, then comes I'm writing p is equal to p plus 1. What is p? What do you have inside p? P contains 1x1. P contains 1x1. P contains 1x1 plus I'm telling to move forward by one location. Okay, but where should I take that step? Go and see the data type in front of it. I have written int. Int means right now I'm considering a 16-bit operating system, so integer size is 2 bytes. So I'm taking two steps. So what is my p value is getting changed to 1x3. Correct. Okay, correct. This is correct. Then if at all I write over here p is equal to px2, then what happens? This becomes base address is same 1x1 plus 2 into 2 will move to 1x5. 1x5 not 4. 1x5, see, 1x1 plus 4 becomes 1x5. 1x5. Is this clear, guys? Okay? Okay. Now I'll write a printf statement. Printf %d, okay, star p. Now what is the value present at p? 1x5. I replace it, no? I have just replaced it. P plus 2 has been stored in p. So now p value is 1x5. Now right now the p value is 1x5. I have changed it. Right now my p value is 1x5. What is the data present at 1x5? Don't know. Go and see from 1x5 how many bytes has to be allocated. Okay, I am going and seeing. It's int. That means from 1x5 access 2 bytes. In the complete 2 bytes we have 3. In the complete 2 bytes we have 3. So the answer is 3. Okay. The same thing. If at all I go with char, then what happens? Okay, I'll just make some changes also in this. I'll write here some 321. This is 322. This is some 3 324. Okay, 324 is okay for me. This is 325. 325. Okay. This is 320's binary format, so I'll just copy it. Okay, you understood, right? This is 320. 321 means okay, one data bit will be. Copy this. This is one. Okay, this is how the data will get inserted. Okay, like I'm showing you how exactly the data will be stored in each location. No, something happened. I'm just removing it back. Okay, let it be like this. Okay, then comes now if at all you write like this, then what happens? I have written p is equal to p plus 2. 1x1 is my base address. Then 2 steps I have to take forward. Then every time increment by 1 because it's a character type. So right now I'm at which location? I'm at which location? 1x3. What is the value present at 1x3? It's it's 65, correct. It is 65. The value present at 1x3 is 65. That is correct. Only one member has given me the right answer. What about the other people? Yeah, correct. Yes, done. Okay, you understood this, right? This is the pointer incrementation. Okay. If you have a single dimension array, we can directly use this. You can use the pointer, and if at all you want to go one byte, you can. It is possible. You can directly go with the two bytes. Okay. Here also float is not possible because in the float you have a mantis and again integral part and decimal part. Two parts will be there. No, so you may not get the expected answer. Okay. Is it okay, guys? Then this is about the pointer. Let us go with the 2D arrays now. What is 2D array and how the pointer incrementation is done in 2D arrays. So if at all we write 2D array like this, A of 2, 3. Done. Thank you for responding. Chal. Then if at all I have written int A of 2, 3. What does it mean? 2 into 3 is 6 into 2. That means I just want a continuous 12 bytes of memory. It's a request from my side. I want 2 into 3, that is 6 into 2 becomes 12. I just want continuously 12 bytes of memory. And you split into two parts. First part and second part. Two rows. Two parts. And in each part again make 3 slots. That is the meaning of this. Okay? Is that clear, guys? Then, now my first question for you is, can we make these two empty like this as we did in a 1D array? If you write like this, no is the correct answer. Okay, no is the correct answer. Okay, what happens if at all you write? No, we can't. Yes, you can't write like that. Okay, what happens if at all you write like this? What happens means that this can be stored like this. First row 1. In the second row, it may get stored as like 2, 3. It is completely don't know how the data has to get stored. How many rows and how many columns we don't know. Okay. So is it okay if you write only the number of rows? Just let us see. Number of rows. Is it okay if you write only the number of rows? I want 2 rows. I have written I want 2 rows. Okay. Split in a 2 rows. So if at all I write in 2 rows, I may write 1, 2 in the first row, and in the second row, In the second row, I may write 3, 4, 5. Is it correct? Have we split it correctly? No, wrong. Because it is not in a correct way. You can split only 1, 2, 3, 4, 5 like that, right? So it's not correct. That is the reason this time what we try is, we try to give only the column numbers. We try to give only the columns. I'll give only the column. I have given 3. 3 means whatever you have, split into 3 columns. Okay, done. I have only 5 numbers here. I'll split into 3 columns. So 1, 2, 3 is the first column. Then coming to the second column, I'll write here 4, 5. And the last one, I don't know because I have not given. I'll write here 6 for a while. I'll tell you why I have written, why I have kept empty also there. Okay, now this will be filled with, now the last one will be filled with 6. Last one will be filled with 6. Now is it okay? Yeah, we have filled correctly. See, 2 rows. Okay, that means it is mandatory to fill the columns. We can't keep both empty, but we can keep the rows empty, but we can't keep the column empty field. Okay, and columns must be given. Okay, columns number must be there. Okay, it's mandatory to have a column number. If at all you don't mention the column number, you can both has to be mentioned, or else at least column number has to be mentioned, or else it will be a blunder. Okay. Okay, I hope this is the syntax. That's it. If at all you don't keep here, then what happens? By default, 0 will be filled inside this. Okay, it's not garbage value. By default, 0 will be filled in this. Is it okay? Yeah, number of columns must be mentioned. It should be mentioned. Okay, we can't keep this as empty. This is mandatory. Even though you don't keep the row number, it's okay, but the column number must be there. Okay, so that it will be filled in a correct way. Okay, done. Now again, the same thing. We know what is A. What is A's value? What is A? A is a variable which is remembering the base address of this complete location. What is the base address of this complete location? 1x1. Done. 1x1 will be given. What is address of A? 1x1. Correct. Then what is address of A of 0? Address of A of 0 is the base address of this location is 1x1 again. Then what is the address of A of 1? What is the address of A of 1? Yeah, guys, tell me what is the address of address of A of 1. This is A of 0. This is A of 1. Yeah, it's 1x7. 1x7 is the right answer. Correct. 1x7 is the right answer. Okay. Then, if at all you write A of 0 of 1, what does it mean? A of 0 means 1x1. What is A of 0? Just now I told you. If at all you write only A of 0, what happens if you write only A of 0? Will it give any number? No. A of 0. Only A of 0. If you give only A of 0, what happens? Yes. A of 0 means 1x1. Base address 1x1. Okay. From 1x1, this one will be treated like this. From 1x1, 1x1 plus 1. That means go one step ahead by 2 bytes. Okay, 1x1 of 1. That means 1x1 of 1 becomes 1x3. So we are moving to A of 0, 1. That is how the things works. Is it okay, guys? A of 0, 0. Is it okay? Previously, I have written it over here like this. A of 0, 1. Okay. Then, this also can be written as the splitting just now we have done. Star A of 0 plus 1. The previous splitting we did know. A of 0 can be written as star A of 0 here. In the previous 1D arrays, I told you A of 0 can also be written as what? A of 0 can also be written as star A plus 0, right? It's a function. Like parenthesis has to be there. Star A plus 0. Okay. In a similar way, this A of 0 of 1 can also be written as, we are splitting it. I'm just splitting it, expanding it. A of 0 is considered to be one element, like one variable. of 1, star a of 0 plus 1. We can write like this. Then again, we can split again. Star of this a of 0 also has been expanded in this way. Okay? All this will give you the same answer, that is 2, 2, 2. This 3 will give you the same answer, that is 2, 2, 2, 2. Okay, guys? Done. Okay, then. Then, now my question is, can we write this in a pointer by using a pointer also? Yes, we can. Then how? The same way what we did previously. Okay? But here you need to remember one thing. This is the formula. Previously, whenever I said pointer incrementation, p plus 1, right? In a single dimensional array, it will move in a normal way, 1, 2, 3, 4, 5, 6 way. But coming to this way, coming to this particular 2D array, it is quite little bit different. Okay? Okay, let me tell you clearly once again what happens if you write like this. What is P? P is nothing but 1x1. 1x1 plus 1 means what? 1x1 plus 1 means percentile D A of 0 is 1x1 or 1. This is 1x1. It is not 1, it's 1x1. It's an address. This complete location, this first one, this complete location is A of 0. This complete location is A of 0. Okay? This complete location is A of 1. If it gives 1, it will be partiality with 2 and 3, no? How? Why should it give 1 only? It cannot give 1. Because this A of 0 means this complete first slot becomes A of 1, A of 0, A of 0. Okay, that's the reason it is giving you address, not the element, not the data. Okay, ma? Okay, then A of 0, 1. Here I am mentioning clearly in A of 0, A of 0 means 1x1, no? A of 0 means 1x1, right? A of 0 means 1x1. 1x1 plus 1 means 1x1 plus 1 means what? I'm at 1x1. A of 0's base address is 1x1. 1x1 plus 1. That means move ahead, move forward. If you move forward, I told you this square brackets will work as a star pointer. That's the reason I split it again here. This is considered to be like this. This particular one is considered to be like this. See this? You will understand clearly now. Value presented 1x3. This is into data type. Into data type. Is it clear now? Is it clear now? Shall I go further? Okay. Sure. Okay, I'm going further then. Now, I have written over here P plus 1. What is P? P is nothing but 1x1. Because I have given the base address of A, 1x1. 1x1 plus 1 means go ahead by 2 steps. Because integer, no, 2 steps. Okay, I'll be at 1x3. Again, if at all I have written the same instruction again and again, what happens? See, I'll write the same instruction again and again. Control C. And I mean to say, I don't print. I just write P is equal to P plus 1. You just tell me what happens if it all we write P is equal to P plus 1. What is it right now? What is the P value? Let me write these two instructions 3 more times. Also, I can use for loop also. But right now, I'll just do copy paste. Yeah, tell me. What is P is equal to P plus 1? P plus 1 means what? P is 1x1, right? 1x1 plus 1 means this one will move to here. This one make my P as 1x3. So what's the value present at 1x3? 1x3 is 2. Again, I am making my P2 increment by 1 again. So this will go with 1x5. So the value present at 1x5 is 3. Again, I am writing the same instruction again. P is equal to P plus 1. Yeah. Done. Again, I am writing P is equal to P plus 1. What does it mean? I am moving to 1x7. 1x7. What do you have in 1x7? That is 4. Okay. That means when you take a pointer variable and you can write this as a single you can access single element like this, like by moving continuous way. So what I mean to say over here directly is I can write, instead of writing like two dimensional elements like this, two dimensions like A01, A01 like this, instead of writing like this, I can directly write A of 1. I can directly write over here also. Oh, sorry, I wrote wrong. A of 1, A of 2, no, sorry, I wrote wrong. This is not possible. Star A of 1. P means 1x1, no, I can write over here. Star A, yeah, I can write, no, nothing, yeah, I can write, nothing will happen. Yes, we can write actually. Star A plus 1. Yes, we can write. Okay, let us all try this also. Instead of writing P, because P and A are same, right? So why don't you write A only directly here? Why don't you write A only directly over here? Everywhere. We are incrementing A. Incrementing A is possible? No. Increment of this complete area is A is, oh, sorry, this is also not possible. Why? Because I'll tell you. Okay, I'm making you confused. Sorry, I'm making you confused. Okay, let me. Is it clear till here? Is it clear till this particular point? Pointer incrementation, is it clear? Okay, then. Sure. Then, here we are accessing like a 1 by 1 bit like this, okay? If at all you want to access directly, like you want to go to the fourth one, and how you are going to access in a 2D way. The accessing of 2D way, you are going to write like this. This is the formula for accessing in a 2D way. This is my pointer. Which row you want, I'll write here. Star, P in the sense 1x1, P in the sense 1x1 plus. I want to have in the first row in the sense I'm talking about A of 1, first row, and in that I want the second total number of columns we have is 3 columns we have. Total number of columns we have 3 plus I want to access the second column element. So I write here second column element. This is a formula. If it instead of writing A of 0, 1, if at all you want to write with the pointers, then you have to write like this. If at all you want to write with the pointers. Control C. See, A of 0, 1, right? If at all you want to write with the pointers, then how you are going to write this? You can't write directly P of 0, 1. You can't write like that, directly like that. Using the pointers, you have to write like this. Star P base address plus which row we want? We are in which row? We are in 0th row. So 0th row. How many total number of columns are there? I have 3 columns totally. And which column element you want? I just wanted to have the first column element. Okay. This is how we are going to write it. Okay. It's plus 3 only, ma'am. Sorry, it's into 2. It's into, correct. It's offset now. Every time we are going to increment by multiply by 3. Done. Sorry. It's multiply by 3. Okay, this is how we are going to write. The same program you have in a hacker rank. Okay, the same program you have. They have asked you to access the 2D array using a pointer variables. This is how you are going to access which row you want and total number of columns and which column you want in that particular row. Okay, this can be written like this. Okay, this is the syntaxes. Now we have studied the syntaxes. Now let's go with the programs. No, first I'll tell you the methods. Okay. Now first I'll tell you the methods, important methods. We have three important methods in arrays to solve all automata questions. These three methods are very important. Okay. All the automata questions depends upon these three methods only. Okay. The first one is comparison method. Comparison means finding the minimum maximum. Okay. Let us do a few as well. Number of times a particular element has occurred. How many duplicates are there, like that. Okay. Let me give you one example for comparison model. I have A is equal to, I'm taking a single element array, integer type, integer array, not character array. I'll take like this, and I'm taking numbers like this: 5, 6, 7, 4, 3, 5 again, 9 again. Okay. First, what I want is, I just wanted to first I do minimum, finding minimum and maximum. Okay, can you all write a program to find the minimum? Please write the program now. Find the minimum number and find the max number. Find min and max number. Find the minimum maximum number in a given array. Fast. I'll compare A of 0. First, I'll consider two variables, min and max. Write the program, please. It's a 3-line code. Just write the code, all of you. I know it's 3 and 9, but I want a 3-line code. It's a 3-line code only. At least you write in your notes. Take a pick and post. Min is equal to A of 0 as well max is equal to A of 0. Then what we are going to do? We are going to compare. What's the comparison? What's the comparison? Please tell me the comparison. We are going to compare all the elements. Already we have assigned A of 0, so I don't write I value. I'll just directly write I is equal to 1 because I'm not comparing with A of 1. Yeah, okay, done. I don't compare with done. Correct. Then I'll go till length of an array. Length of an array is number of elements we have over there. Okay. Yes. Cypriya, you wrote correctly. Yes. If at all. If at all, A of I is nothing but A of 1 is greater than max. It is greater than max. Then allocate max as A of I to maximum element. That's it. Correct only. You people wrote correctly. Okay. And for minimum, you're going to write less than symbol. That's it, no? Yeah, correct only. That is how you're going to write it. Now, in this particular one, I want how many times 5 has occurred, 6 has occurred, 7 has occurred, like how many times each element has occurred. How do you write that particular program? How many times 5 has occurred, 6 has occurred, 7 has occurred, like each element, how many times it has been occurred. . Now I'll take some key element k is equal to 5. I just wanted to find how many times array index create array whose index is what is this, Saujanya? Create array whose index is array element. Okay. Okay, fine. Right now I'm finding key element 5. How many times it has occurred? What do you do? Here we just simply write a of I equal to k, and this time I value will be starting from 0, and I'll take one extra variable counter, c is equal to 0, and whenever this get matched, I'll just increment my counter value. That's it, no? And that c will be my number of times k occurred. Yes or no? Yes, correct. Done. Now, my next question for you, this is very, very important, and that we call it as a frequency array. This is comparison model, like we are comparing less than, greater than symbols, how many elements are greater, how many elements are less, how many times occurred each element. This is comparison, okay? Now, the second one is frequency array. I'm converting this program into frequency array. Now, I want the output like this. What I want is, I want in an ascending order. Like here, 3 occurred how many times? 3 occurred once again, comma, 4 occurred once, 5 occurred twice. I'll just repeat the same thing. I'll just write 7, 7, 7. 3, 4 times 7. 6 occurred once, 7 occurred twice. I want in this way, ascending order, that too how many times each element occurred. 4 times, sorry. 4 times. Thank you. Okay, tell me now, how do we do this? How do we do this? In order to do this, what we do is, this method taking 2 loops. No, actually not required. Just see. I know you might be doing this only because in the college we have done this only. But see, I'll tell you one. This is very important and it's very simple also. Okay. This method is called frequency array method. There is nothing called frequency array. I only named it because I like the name. Okay. There is nothing called frequency array. I only named it because I liked the name. Okay. So just see the method now. What we do is, first I observe my numbers are less than 8. So I have taken a frequency numerical array of f of 8. Then I have allocated all of them to 0. I'm comparing my index value with the array element. Yes, Cyprian, you told me correctly only. Increment a particular index value. Correct. Okay. Then what happens is, a frequency array will be a frequency array of f. F is my frequency array or count array, I can say. Count array, I can say, or frequency array, I can say. Okay. What I did over here is, I have taken f of 0 to f of 7. Okay. F of 0 to f of 7. Then I'm counting, if at all, my I is nothing but index value. I is ranging from 0, no? I is nothing but 0 is equal to a of I. I'll make it as j and then I'll decrease this. Okay. For j is nothing but my index value, which is ranging from length L j plus plus. What I'm trying to do over here is, I just try to find how many times this has to be done. Okay. If at all I is equal to a of j, then I'll explain you within a while. Then what I do here is, I'll just write f of I is equal to f of I plus 1. I'll minimize this code also. See, first, what is my I range is from 0 to 7 only. Okay. Why I have taken 7? Why? Because my elements are less than 8. That's the reason I have taken it max as 7, equal to 7. Okay. First, initially, what is my f of 0? f of 0 is equal to 0, f of 1 is equal to 0, f of 2 is equal to 0, f of 3 is equal to 0, f of 4 is equal to 0, like that. This particular one is all zeros only. F of 0 is equal to 0. I'll take a text box, I'll write in text box. Writing on a PPT is really very difficult. This particular thing happens whenever you have to. I'm creating a frequency array. This model is very important, especially for automata, because I have seen 6 questions based upon this only. 6 papers I have, and all of them contains at least one question on this. Whenever you write a frequency of 8 of equal to 0, this happens. Okay. Then now what am I doing is I'm trying to compare this inner index values with this particular element a of this array values, array data values. Okay. So first I'll compare I is equal to 0. Okay, I equal to 0. J starts from 0 to L. L is nothing but length of my array. So first one, J is equal to 0. What is A of 0? A of 0 is equal to 5. 0 is equal to 5? No. Leave it off. Again, J value incremented. J value has become 1. So 6 is equal to 0? No. 7 equal to 0? No. 4 equal to 0? No. Then I found, okay, let me write 1 0 also here. I found 1 0. 0 equal to 0? Yes. So go inside and write f of 0 is equal to f of 0 plus 1. What is your f of 0? It was 1. It was 0 actually. Now I'm making it as plus 1. Okay. I'm comparing the index values. This frequency index values with the array elements. Frequency index values with the array elements. Is that okay, guys? Is that okay? Is it clear? I'll just minimize the loops also. Here also I'll just minimize the loops. Is this clear? Shall I proceed further? Yes? Shall I proceed further? You have any doubts? Okay, I'll explain once again. See, what am I doing is, I just want the answer in this way. How many times each element has occurred, that in ascending order. That is my question. You understood the question? In order to find the answer for that, we have 2 ways. One is first sort and find the occurrence of each element, like we did finding a key element. Okay, that is one process. Okay. The other process, which is very small and efficient way, is having one more array and comparing the index values with that particular elements. That is one more way. Okay. The second way I'm explaining, efficient way. This also will reduce again. First, try to understand what I have written over here. First, I am writing this index values. This 0, 1, 2, 3, 4, 5, 6, 7 is there, no? This is all sequential values, no? Whenever you have a sequential values, you are going to write a for loop. Okay, I have written a for loop. First for loop is for this 0, 1, 2, 3, 4, 5, 6, 7 index values. Okay, done. Then I'm comparing how many times this 0 has occurred. This 0 has occurred in this array. How many times this 0 has occurred in this array? How many times it has occurred? Only once, right? Then how do we find that? We find like this. I value is 0. 0 is equal to A of j, where j is getting incremented every time. J is equal to 0. 0 equal to 0, no. 6 is equal to 0, no. 7 is equal to 0, no. 4 equal to 0, no. 0. Now we got 0. When j is equal to 4, when j has become 4, at that time we got A of 4 as 0. 0 equal to 0, yes. So go inside and go to frequency array. Okay, I'm going to frequency array. My I value is 0. So f of 0 is 0. 0 plus 1 becomes 1. So I have replaced 0 with 1 and again store back in f of 0. Is it clear? Is this clear, guys? Now let me trace off with the second one. Let me write here. I have directly gone with Okay. Now I'm seeing, now again 1. I got incremented to 1. But do we have any 1s in this? So this will never, this will be always false. This will never be true. Okay. Again, I value will be incremented to 2 also. There's no 2, so this will be again false only every time. Now again, I value becomes 3. When I value becomes 3, again we'll start comparing. I is equal to 3. J starts with A of 0. A of 0 is equal to 3, no. A of 1 is equal to 3, no. A of 2 is equal to 3, no, no, no. Again, at A of 5 is equal to 3, we found 3. If it all 3 has come, then go and increment f of 3. F of 3 will increment it to 1. Okay. Let us consider after this again I have one more 3. I have one more 3 after 3. Okay. Then what happens is I value will be still, I value has, okay, sorry, I value is 3. Again, I have incremented my j value. My j is at this particular place. Again, this got matched. This particular condition will be true. So go and increment f of I. That is f of 3 was 1. I'm making it as 2. Okay. Is this clear, guys? Now I'll just make changes in this. If you do like this, what happens is, how many times each element occurred, that particular notification will be there with the frequency array. So 5 has occurred once, 4 has occurred once, 6 has occurred once, 7 has occurred 4 times. This is the thing which will be there with the frequency array. Okay, I just try to minimize this. Okay, what we do over here is, what I'm trying to find, okay, I just remove this for loop also. Why I'm removing, I'll tell you. I'm writing over here directly A of I. Sorry, I must have written A of J. Length of my array. I have minimized the loop. See, what I did here is, yeah, yes, correct. We can write even plus also. That is also correct. Saujanya, you wrote correctly. That's the reason I have changed my array length to 7. Okay, L, length of an array. Okay. So first what I'm trying to find is A of 0. What is A of 0? Is 5. A of 0 is 5. A of 0, I is equal to 0. A of 0 is 5. F of 5. Go to F of 5 and increment the value to 1. Okay. I'm just incrementing the value to 1. Again increment I value. This time I becomes 1. What is A of 1? A of 1 is 6. F of 6 plus 1. Go and increment F of 6. Okay. This is nothing but your frequency array program. Okay. This is how we find the frequency of each element. Okay. Now from this question, from this particular question, in the automata itself, they have asked 7 questions. The questions were, you need to find how many duplicate elements are there, how many unique elements are there. Yeah, you have any doubt? Someone is asking me. Yeah. Can you please repeat your question? What is your doubt, ma? Shall I proceed further? Okay, after writing this, if it all we write for I is equal to 0, I is less than or equal to 7, I plus plus, printf, percentile D, f of I, sorry, it is not f of I, two things I need to write because I need to know which element has occurred, no? Which element has occurred how many times? I, comma, f of I. And I said I want in between some dashes also, hyphens also. So this will give me this answer. Like 0 has occurred in that in ascending order. 0 has occurred once, 3 has occurred twice, 4 has occurred once, 5 has occurred once, 6 has occurred once, 7 has occurred 4 times. Okay. And is it the answer it is going to give? No, it is going to give even this also. 1 has occurred 0, 2 has occurred 0. So I don't want this. How shall I remove that? By writing additional statement. What is that additional statement I need to write? This printf has to be printed only if f of I is not equal to 0. Only if f of I is not equal to 0. Or else printf should not get executed. Okay? Now in this, I'll ask you questions. The questions are, can you tell me how many duplicate elements are there? Duplicate means which has occurred more than once. Okay? Okay, if you don't, you have array randomly. Yeah, the problem with this particular program is if you have the numbers like 7,000, 70,000 like this, okay, then you can't find a frequency array, right? At the time you have to go with the normal count variable, count incrementation. The first one, comparison method, C value, counter incrementation. Okay, if you have limited elements like less than 30, maximum less than 30, then you have to go for this kind of elements, this kind of method. See, to your question was very good. Okay, you understood? This is an efficient method only if you have a limited number of elements. Like less than 100 is also okay, but not in this way. 1700, 70,000. Then this is not an efficient way. You can't go with this particular method. Okay, then you have to go with the normal counter method. C count method, like C++ method. Okay, count method. Is that okay, guys? Now from this question, they have asked 7 questions repeatedly, the 7 different questions like this. How many duplicates are there? And how many unique elements are there? How many are missing? Okay? Okay, ma? Is it okay? Can you write those programs? You need to change only this particular part. Can you find the duplicate elements? I want the number of duplicates. Can you write a program to find the duplicates? Please write a single line instruction. Here you need to change something to find the duplicates. To find the duplicates here you need to change something. Tell me how many duplicate elements are there. Just change this particular part. Just change this particular condition. That's it. If f of I is greater than 1, correct. That's a duplicate. How many unique elements are there? How many duplicate elements are there? Duplicate is done. Unique elements are there? Done. Yes, correct. Done. You're doing well. Now the last one, the last method was traversing from both ends. Okay, the last method is traversing from both ends. I'll just remove this or else I'll go with the new slide only. Let me consider an array. Again, numerical array. I can take any array, but I'm taking numerical array right now. 2, 4, 5, 7, 8, some numbers are there randomly. Any numbers. Now what I do is I want to have a reverse of an array. I want to do reverse of an array. Reverse of an array. This method is also very important and efficient too. Okay. How do you do the reverse of an array? Generally, we'll take 2 variables. I is equal to, these are the index values we have. The index values are the index values are 0, 1, 2, 3, 4, 5. Okay, these are the index values. So I'll take here 2 variables. One is I equal to 0. Other one is j is equal to length minus 1. That is, I have 5. Without knowing the size, without knowing the size, you can't run. You have to compulsory find the size. I'll tell you how to find the size because that is also one of the automata question. In automata, they have given this question also. We'll find the size. No, not, I'm not talking about printing. If at all I print array itself has to get changed. See, if at all you're printing from backward, it's okay. But I want you to change the array itself. Array has to get changed, not printing. Array has to get, internal values has to get changed. Okay? Without knowing the array size, really we can't do. First, you need to find the array size. Okay, I'll tell you how to find this array size. We know array is nothing but a continuous memory. So we have one operator which is directly related with the array, that is size of A. Size of A means it will directly give you how many total number of bytes allocated for that. Total number of bytes allocated is 12 right now, which is 12 bytes, right? 12 bytes by size of the first element. Size of A of 0. What is size of A of 0? That is 2. Okay. What is 12 by 2? That is 6. 12 by 2 is 6. So you have totally 6 elements. You have totally 6 elements. So my J value, I'll write like this. My J value would be -1. That is, it will give me 5. -1. This would give me 5. Okay. J is equal to size of, this is the form. This is the length. This is how we find the length. This is how we find the length of an array. This is a single line instruction. But this works only if at all you have nothing here. If at all you have nothing inside this, then only this works, or else it won't work. I told you this has got a problem that we are going to clear when I'll tell you a stack program. Okay? Chalo, let us go further. I have assigned I and j values also. Now what I do is I'll swap I with j. I is equal to 0, j is equal to 5, right? So I'll swap it. So when you swap it, how do we swap the elements? A of I, that means A of 0, has to be kept in temporary variable first, or else I will lose my data. Then whatever you have in A of j, that you store it in, whatever you have in A of j, that you store it in A of I. Whatever you have in A of j, that you store it in A of I. Then whatever you have in temp, store back it in A of j. Okay? Store back it in A of j. But this particular process, first I have swapped 2 with 9. Now this 2 has been replaced by 9. And this 9 has been replaced by 2. Array itself is getting reversed. Okay? Then I have to increment and decrement my j values, right? So I'll write over here. After that, I set for initially I equal to 0. J already I have given. Comma. J is equal to 5 already I have given. Semicolon. Till how, like I don't know till which part I have to do. So I'll make my condition part empty for a while. I'll try to make the conditions also. I plus plus and j value has to get decremented, no? Why? Because this time I'm going to swap 1 with 4. A of 1 with A of 4. So that's the reason I'm incrementing my j value and decrementing my I value and decrementing my j value. Okay? But after incrementation after incrementing I and decrementing j, I will be 1, j will be 4. I'll swap both of them by using this method swapping. Okay? Then when I swap, this will become 8 and this will become 4. Done. Again, I need to increment my I and I need to decrement my j. Okay, I have incremented my I to 2 and j to 3. Done. Again, the swapping of these two also have been done. 5 and 7 also got swapped. Then if at all I increment my I becomes 3, and j becomes 2. Should I swap again? Should I swap again? No. That means the swapping process has to be done until I is less than j. Is that okay? The swapping process has to be done until I is less than j. When I is going beyond j or equal to j, we should not do any swapping. This is how we do the reverse of an array. Okay? Any array, it can be a numerical array or character array. Reverse of a string has to be done like this. This is the program for reversing a string, reversing an array elements, reversing any array element, float array, any array elements. Okay, done. Is this clear, guys? Is this program clear? Shall I go further? Yes, shall I go further? tell me? Okay. Okay. We have one more. Okay, done. Okay. Chalo. Then, now based upon this model, they have asked 3 questions. One is, check whether a given array is a palindrome array or not. Now, within 1 minute, you have to tell me, like, is this a palindrome array or not? What is the change in order to check whether it is palindrome or not? Should we do swapping? Should we do reverse? Complete reverse is required? Or else comparing A of 0 and A of 5 is okay? First, I'll compare A of, if at all, I'll write here. I'll just don't do this. Swapping and all is not required because we are using 2 variables at a time. One is at one is at the first end, and other one is the second end. So I'll just compare. If at all, A of I equal to J, then continue. Continue. Okay? Okay, continue. Else, break. Okay? Generally, we don't write this much of code. What we do is we'll write break only in the if. Okay? We do like this. And we don't know we have break because of the condition failed or because of this condition failed, because of the if condition failed or for condition failed. In order to predict that, what we do, we use some flags. Flags in the sense some watchman kind of thing. Initially W equal to 0. If at all we have break because of this else part, so I'll make W is equal to 1. I'll check. After coming out of this for loop, I'll check it out. After coming of this for loop, I'll check it out over here. For loop and by question, I'll check it out over here. If at all my W equal to 0, then the given array is a palindrome, else not. Printf palindrome, else not, else no. Okay. I'll write over here, else not a palindrome. By this, what happens is the comparison time will get reduced. Okay. So generally we don't write this much of code also, but in the automata they have, in order to confuse you, they have given this bigger code, but not required. We simply write if it is not equal to a of what is this A of J? Okay, the last one, right? So break. This is sufficient. As we have 2 statements, I need to keep a bracket. Okay. This is how we check whether a given array is a palindrome or not. Okay, this is the program for checking a palindrome. Is it okay, guys? Okay. So in this particular slides, I told you what is an array, why we have a concept called array, then how to access the array variables with the pointer variable, and how to access 2D array variables with the pointer variables. As well, we have seen 3 methods. One is traversing from both the ends, like reversing or palindrome. In this, we have seen how to travel from both ends. One I kept here, one variable I kept at the end, and I'm incrementing this and decrementing this. I'm traversing from both the ends. This is one method. Okay. This method is very simple and easy. On this method only we have got so many problems. Then the next method I told is frequency array. That frequency array program would help you in finding the duplicates, unique numbers, such kind of things. Okay. Then consecutive elements or consecutive numbers are present or not. Such kind of programs that frequency array would help you. Okay. Then now we'll go with the functions concept. First functions concept. After finishing of the functions part, I mean to say syntaxes, then we'll go with the MCQs and no, first we'll go with automata, then we'll go with the MCQs on arrays. Okay, chalo then. Oh, not this. Okay, what is a function? Instead of writing the same code repeatedly, what we do is we write the function code once and call it at different places as many times we want. So did I say the same statement before also while writing a for loops? If at all you want to repeat the same statement again and again, we'll go for the for loop. And I'm saying the same statement again. If at all you want to repeat the same code again and again, then we have to go for the for loops. What is the difference between these two statements? What is for loop and what is an array? In the for loops, whenever you have a continuity, like the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 continuously, then you go for the for loops. But whenever you have different values, but you want to execute the same code, then you have to go for the functions. Okay. I'll go with the simple. The functions are of 4 types. We can write the function code in 4 ways. No parameters, no return type, parameters, no return type, no parameters, return type. These are the 4 kinds of functions we have with parameters, with return type. With simple example, I'm trying to explain you. This is very simple and very easy. We try to understand function with arrays, function with the pointers. Okay, function with structures. I'll tell you when I'll deal with the structures. Tomorrow I'll tell you. Okay. Now today we'll go with structure functions with pointers and arrays only. Okay. So this is my program. This program, only this program, one program will be explained in multiple ways. Addition of 2 numbers program. Do you feel anything wrong in this code? Whatever I have written? Anything is wrong in this code? Yes guys, anything wrong in this code? Everything is perfect? I want you to answer me. Yes, everything is perfect? 100 should not be there. Why? Why? Who will call this main function? Are we calling, whenever you have these brackets, that is called function. But are we calling the main function or someone is calling the main function? Automatically called. Automatically, who will call this? There is one constructor for every program. That compiler will first execute the constructor. That constructor is going to call this main function. Okay? But whenever we call any function, function has to return something. Okay? I said I'm going to return integer type. Okay, 100 is not an integer type. 100 is integer type only now. So there is nothing wrong if you write 100 also. We can write any number. I said I'm going to, if at all you call me, I'll give you integer number. Okay. I'm giving you integer number only. See, this is not an integer number. So nothing is wrong in this. This is correct. You can write any number. Instead of zeros and ones also, you can write any number. Nothing is wrong in that. Okay. Now, this code only I'm explaining using a functions. Okay. So the first function. We can write the functions in one first way is this. Function. If at all you want to use this function, you have to tell the compiler that I'm going to use a function. This is called declaration section, which has to be done before the main. So you might have a doubt also. We have to write the function about the function. Yeah, we can write here. This is called declaration function. Declaration function will be called inside the main function. Function will be called inside the main function, and function definition will be there after the main function. Okay, this is called definition. If this is called declaration, declaration says this has to be used and this has been called in the main function. After calling is been done, when you call, it will go and in search of what has to be done. This is the definition. Addition of 2 numbers code is this. Okay, or else we can write in this way. Just write declaration and definition has been written above the main, and calling will be done inside the main. These are 2 ways in which you can write a function. Okay. These 2 are correct only. These 2 are correct. We can write in this way or this way. We can write this way or this way. Okay. Now my question for you is, the first one, what are we doing? The program starts the execution from the main function. Okay, main function has been called. Then inside the main function, first line is add, you're calling it add. So it will go to add function. Then two bytes of three locations will be allocated, one for A, one for B, and one for C. And using a keyboard, I'm writing the value into A's location and B's location, and I'm computing C is equal to A plus B. I'm printing the answer there itself. After printing, what happens? After printing will come out of this particular add function, where the compiler will go. Now where the instruction has to go, where this cursor has to move, it will come out and come down again like this, or else it has to come to or else it has to come here. Where it has to go? It has to go to the next add, right? So for that, what I do is I'll simply write return. This is a good practice if you write return. If it is not there, no problem, but it's a good practice if you write return. Return nothing. Return nothing. Simply return. We can write only return also. Simply return. Go back. It's a good practice for the beginners. Not for all. For the beginners, it's a good practice of writing return. Go back. Okay, I'm going back. I'll come here. Okay. After printing the answer, I'll come back. Now the question is, do we have this A and B values existing after coming back? No. When the function is being called, immediately these locations will be given by the operating system, and when you're coming out of this function, these locations will be taken back by the operating system again. These memory locations will get destroyed by the operating system. Again, operating system will take back those locations. Okay. Now there is no name, there is no fields like A, B, and C. Once you have come back, again, when again add is called, we go back again. Memory for A and memory for B and memory for C will be created, and we are writing new data into that. Again, new data will be computed and printed. And I'm saying go back. Okay, I'm coming back. Okay, you understood this code? It's addition of two numbers only, very simple code. In the automata, they'll give you only function and they'll ask you how to call a function. That's the reason arrays with function has been said, because all the automata questions are like that only. Functions has to be called. Okay, functions has to be called with arrays. So that's the reason I have to take this particular thing. Okay, done. Shall I go further? Yes, guys, you have any doubt? You know this, I know, but still, it's my duty to explain you once again. Again, what I do over here is the first one is called no parameters and no return type. I'm not returning anything. No, I'm not returning anything. No parameters and no return type. I'm not returning anything. I'm returning nothing. Simply I'm coming back. I'm not giving anything. So this is called no parameters, no return type. No return type. No parameters and no return type. No parameters, no return type. Coming to this one. This is called with the parameters with no return type. With the parameters and no return type. Okay. So the function will get started from main function. I'm passing the parameters here 5 and 8. 5 will be stored inside A and 8 will be stored inside B. And here this A and B are called formal arguments, and this 5 and 8 are called actual values. These are called formal. Okay. So temporary storage areas. 5 will be stored in A and 8 will be stored in B, and values will be computed and result will be printed on the screen here itself. It is not giving back anything. Okay, like that 3 times we have called the same function again and again with different values. Okay, this is called function with return type and no function with with parameters and no return type. And the next one is, here I am calling a function with no parameters but return type is there. It is going to return me integer type with return type. So here I just want to add two numbers. I'll go to add. I'm using a scanf statement. I'm reading two values into A and B locations. Then I'm computing the sum and returning back. Return is a keyword, so it must be in a small case. Return C. C. What is C? C is of which type of variable? C is of which type of variable? Integer type of variable. So I need to tell to the function that prototype must be integer type. I am returning an integer type back. I'm returning integer value back. Am I making you bored? Guys, am I making you bored? Shall we stop this and shall we go with the arrays multiple choice questions? Okay, I'll stop here. I'll go with arrays multiple choice questions. Okay. I'll stop this. I'll go with the arrays multiple choice questions. Okay. For a while, we'll have this. We'll see this. You just answer me the questions. What is the answer for the first one? C. Wrong answer. For A option is correct. Why? Why? Because size of will tell you number of bytes occupied. It's a character type, character array. So one for this, one for this, one for this, one for this, and even though you don't mention, strings ends with a null character, right? So that is the reason 5. No, strings ends with a null character. So 5 bytes got allocated. Oh, yes. Size of means 5 bytes got allocated. And how many characters are there in that? Only 4. 5 bytes got allocated. How many elements are there in that? Only 4. So it is 5, 4. Okay, 48 you wrote wrong, and rest of all correct only. Priya also wrong. Okay. Totally 5 bytes got allocated. 1 for C, 1 for D, 1 for E, and 1 for F, and 1 for null. Okay. That is size of. Totally 5 bytes got allocated. strlen will give you only the number of characters. 1, 2, 3, 4 characters are there. So it is 5, 4. Is it okay? Next one. Yes. Answer for this. What is answer for this? Yes, guys. Tell me the answer for this. 1, 2, 3, 4, 5, 0 is the right answer. Correct. Because the last one we haven't read. We did not mention the last one. So, no, it is 0. See? 2 by 3, no? But how many elements I have mentioned? Only 5. But we are reading all the elements. We are trying to read 0 to 2. That means 2 rows we are reading, 3 columns we are reading. So, the last element would be 1, 2, 3, 4, 5, 6. 0. Okay? Correct. This one is quite interesting. Just tell me this one. Guess the answer for this. There's no multiple choice question. It's a direct question. Like 1 mark question. Fill in the blank kind of thing. What is an output for this? 3 to 15. Is it so? Why 3 to 15? 2, 3, 20. Okay, let me do first. I is equal to, I wrote the plus a of 1, no? So what is a of 1? A of 1 was 2, so I'm making it as 2. A of 1 was 1, I'm making it as 2, so I is equal to 2. J is equal to A of 1. A of 1 just now I made as 2. So it becomes 3. A of J only 2, but the A of 1 place becomes 3. So I'm writing M is equal to I. What is I? I was 2. So A of 3 becomes, what is A of 3? A of 3 is 20. So the answer is 2 to 20. 2, answer is 3 to 20. Okay, Saiti, you wrote correctly, but order is wrong. The answer is 3 to 20, no? We are incrementing I at the end. Answer is first here. What am I doing? In this, A of 1 is becoming what? A of 1 has changed to 2. Correct? A of 1 has changed to 2. Okay? So I value is 2. This is my I value right now. I value is 2. Okay? Then again, J. What is A of 1? Right now we have, right now, it's a post increment node. So J would be 2 only. J would be 2 only. And A of 1 is getting incremented. So A of 1 we are incrementing to 3. A of 1 is being incremented to 3. A of 1 is being incremented to 3. We are this incrementation operator is there in A of 1, not on J. So it's a post increment. First allocate and then increment. Okay, that is how it got changed. Then M. What is A value? I value. A of I is 3. I is 3. So we are incrementing 3 value. A of 1. Okay, one second here. I is 2. So I value is getting incremented, so it becomes 3. What is A of 3? A of 3 is 20. Okay. And I value also got incremented, so it is 3. So the answer is 3 to 20. Is it okay? None of you have given the correct answer. Why? Saujanya, Shrisha, Kumari, Sai, many of you have given the wrong answer. Okay, done. Okay, that is how we are going to do line by line. Actually, here writing problem is there for me. For you, it's a book. No, you can write simply in a very good way. Okay, what is the answer for this? Fourth one. Initially, I equal to 0. 0 is less than 5. It's a pre-increment. That means first I'm incrementing the I value. I am making I as 1. 1 will be stored in A of 1. Like that, this will be continuously 4 times it will get executed. Write in a book and do, no? I'm also writing on a paper and doing. Write in a book and do, all of you. Take a block of memory, continuously block of memory of A of 5. Then make the index value 0, 2, 3, 4. Then initially I equal to 0, but I'm incrementing I value. So 1 has to be stored in A of 1, 2 has to be stored in A of 2, 3 has to be stored in A of 3, 4 has to be stored in A of 4. After that, whatever I have stored, I'm printing back. So what you have stored? Wrong answer. Saujanya, little bit correct, but something is wrong. So the first one is not 0. Did we mention over there 0? No. It will be first garbage value, also I can write junk, then 1, 2, 3, 4 is your answer. Okay. Why not 0? You may have a doubt, why not 0? For 0, see, this is a local array. It's not global array. It's a local array. If at all you make it as a global array, your answer is correct. If you make it as a global array, your answer is absolutely correct because global values are by default zeros. Okay. But coming to the local values, like control Z. Okay. Here, what happens is whenever you write like this, equal to something like 1, 2, simply like this. Then what happens is, and remaining values will be set to 0. Remaining values will get set to 0. But am I allocating anything here? I'm not allocating. So all garbage values will be there inside that. So that's the reason. It is first one is junk value or is garbage value, and then 1, 2, 3, 4 is your answer. Correct. People who wrote only 1, 2, 3, 4 is wrong. First A of 0 is junk, garbage value. Okay. Done. Coming to this one. What is the output of this? Okay, here. It is ending here. What is the output of this? Just now we have seen this. What is this program for? Size of A by size of A of 0. This is the program for what? Yes, length of an array. This will give you length of an array, that is 4. Correct. Am I correct? Okay, if I write only size of A, then what is the answer? Only size of A. Like this. What is the answer? No. It is not 8, it is not 4. Yeah, it's 16 because float no 4444 bytes. Total 4444 bytes will get allocated. Yes, correct. What's the output of this? Is it okay if at all you write like this? We are writing the size like first 2 bytes will be allocated, then I will be allocated. Okay, 2 bytes will be allocated for that. Then we are writing size. Then here, this is memory allocation, no? First, when you compile, when you execute your program, first memories will get allocated. Then it will show you the screen. Now we are writing size. Is it correct? Here the compiler will have a doubt. No, it's not possible. Why? Because here the compiler can't allocate the memory for this. Okay, this is not correct. Then how you have to give this? You have to write over here. You can't write size like this. This is an error. This will show you error. You can't write like this. You have to give here. You either you have to directly give the number here. Either you have to give directly number over here. Okay. How can you take input unknown size? This is a good question, C2. Whatever you asked is good question. See, first, I just wanted to have 5 elements. Then what you do is, I'll just remove this. You first declare 1000 because I don't know what is my size. Then I'll ask now, how many elements you want? Then what I do is, I'll write here scanf. I just want I want to read only 5 elements. Read that into some variable n. This n will tell you number of elements you want. This s will tell you number of elements you want. This n will tell you the number of elements you are reading in. Okay? Here again you may have a doubt. If it is like that, then why did we take 1000? Because we don't know previously how many elements we are going to store. That is the reason we have taken by default 1000. Okay? Array is fixed and continuous. We can't change it again and again. That's the reason first only we have initialized. This is the problem we have in arrays. That is the reason the solution for this problem is stack. Okay? I'll tell you this problem again when we have a stack program. And just after 2 days I'll tell you the stack program. Okay? This is how we are going to read the elements. This is perfect program. Okay? Yeah, in the constraint they'll give you, in the constraints they'll give you, like the constraints will be, they'll give you 10 power 3 to, they'll mention array size will be from, array n size will be, they'll mention in the constraints, array size would be from which range to which range. Based upon that only you have to take the array values, array elements. Like they may tell you from 0 to 10 power 4. Then you are going to write it as 10,000. They'll mention in the constraints. Based upon the constraint only, you are going to take the array size. You can't take directly 1000, 10 like that. Okay? You can't give n value in the hidden. Yes, you can't give n value in hidden cases. That also has to be read in the scanf. No. See, whenever you're executing any HackerRank program, what happens is they'll give you already how many elements are there. Okay, that n value you're going to read. In the test case also, they'll mention the n value. Okay, compulsory n value will be there. We are not going to give explicitly. But n value will be given in the input only. In the input, we'll mention n value as well as the elements also will mention the input itself. Okay? But in the constraint, they'll mention you what must be the size of an array. Based upon the constraint only, you have to take. No, you can't take like this. No, this is incorrect. This is not correct. Cypria, whatever you wrote is not correct. Why? Because, see, there is a reason. See, what you wrote is, it's very simple. Sorry. From it is not copying from there. This was there previously. Okay. What is wrong in this is, let me rearrange this so that you will clearly understand. What is wrong in this? First, this part will get executed, not this. Scanf will be run at the runtime. In code also, n values will be given. First, array elements will be, first array size will be given. They'll give you a constraint like this. Array size. What is the array size? I'll show you one example in code. Just wait for a while, C2. I'll show you in HackerRank. Cypria, just see this, and other people also just see in this one. No, once. First, this particular two instructions will get executed. First, we are writing 2 bytes for, we are creating, not we, operating system will create 2 bytes for size variable and 2 bytes for I variable. Okay, then it will come to second line. It is asking us, we are asking us to give the array, allocate a memory for array. How much of memory has to be allocated? Did we mention that? Did you mention that how many bytes of memory has to be allocated for array? This will show you error here. The compiler will get confused. What you are asking for? You just tell me the character size. How much of memory bytes you want? If it all we give like that, now it clearly understands. Okay, they want some 20,000 continuous bytes of memory. Okay, okay. First, this will get executed. Even though you have many number of things in between, like printf is there, anything can be there. This all will be executed later. Like after first initializations will be done, first memories will be allocated, first memories work will be done, allocation of memory will be done. Then after that, these other statements will get executed. Cypria, is your doubt clear? That's what I'm trying to explain you. First declarations are there, no? First memory allocations work will be done. Then in between statements will get executed later. Okay, that is the reason, even though the scanf is over here, even though the scanf statement is over here, this will get executed later after declarations. This will be done later. Like these two statements will execute later. Later in the sense, once it creates a memory, after that memories will get, after that these two statements will get executed. That is the reason this will show you error. We can't write the size like this. Okay? Is that okay, ma? Now this is wrong. This is blunder. Okay, done. Then what is wrong in this? What is correct in this? Sorry, what is wrong? Not wrong. What is correct in this? It is necessary to initialize first one. Array n of 26 have to be stored. We have to store compulsory 26 elements. It's like have to store. Have to store 26 elements compulsory. We have to store 26 elements compulsory. No, it's not required. Okay. Then array index starts with 1, 0. Array index starts with 0. No, array index will not start with 0. Array index will start with 0, not with 1. Then, is it necessary to initialize the array at the time of declaration? Allocate all. Is it necessary to initialize the array at the time of declaration only? Yeah, at the time of declaration only we have to allocate the size. Okay. Then declaration num size is allowed in the size macro. They're asking what is this macro in the sense they're asking you. I'll go with the previous one. Here, if it is like here, hash define size 10,000. Is it okay if it all be write like this? Yeah, it's okay. It's okay if it all be write like that. Okay, it's okay if it all be write like that. That's a macro. Okay, that's correct. So actually two are correct. Then coming to this, what is here? What is the output of this one? What is the output of this one? String length function will give you a number of elements. So this will be giving us 7. Okay, 0 to 7 we are going to access. So every time are we incrementing by 1 or 2? Incrementing by 2. So what is the output? Yes, it is GRAY. Gray. Gray is the correct answer. Yes, gray is the correct answer. Correct answer. Then ninth one. Last one too. No, we have few more. What is the output for this? Do it and tell me. No, do it on paper and tell me. I'm also doing it. 2 by 2 matrix. What is the output? It is asking about the addresses. Continuous memory. Okay. How many bytes difference is there? 1 byte. Only 1 byte. See. A of 0. We are in A of 0 only. We are in A of 0 only. We are in A of 0 only. There's one table here. Okay, done. This is A of 0. This is completely A of 0. This is A of 0, 0. This is A of 1. How much of difference would be there in between them? Only one location, no? Beside neighbors only, no? So the answer is 1. Neighbors. These two are neighbors of each other. So it is 1. Okay? If at all I would have asked you 2, then it's a second neighbor, 2 neighbors. Actually, it is not possible here because it is like this. Now they're asking the address difference only, no? Address difference only. So it is 2. 2 locations. Like from this house, it is beside, like after 2 houses, this particular house is there. Like 2 locations difference. One. Output is 1. They are neighbors of each other. Like beside only that is there. Let us say this is 1x1, this A of 0, this is 1x1. And what is the second location? This would be 1x3, no? 1x3. This is 1x3. 1x1 and 1x3. What is the difference between them? One location only, no? They are different by one location. They are neighbors of each other. If at all you have 1 over here, they are neighbors of each other. They are beside each other. 1. 1 is the answer for this. 1 is the answer for this. If at all you have 1, 0, then it is, let me write down the paper and tell you. If it is 1, 0. Once again, we have this diagram already, no? We'll just go with that. You're asking me the difference from here to here, right? What's the difference? How many locations difference? 1, 2 locations. 2. 2 is your answer. 2 locations. From here to here, 2 locations are different. They are neighbors only, but after the second house, this house is there. Like 2 locations difference. Understood, ma? Okay? Is that okay? Yes, done. Now tell me the answer for this. Make it fast now, little faster. What is the output for this? Sirisha, tell me the answer. Sai Priya, C2, Kumari, Saujanya, please tell me the answers, all of you. Shrija is not there in the class today. It's 1 and 6. What is the answer? I'm also doing it. I have replaced f of 1 0 with f of 0 1. So it was 1 2 3 4 5 6 0 1 0 1 2. So what we did is 0 1 element. 1 has been 4 has been replaced with 1, right? 4 has been replaced with 1. Then now f of 1 0 is 1, comma f of j becomes 1 and I becomes 2. It's 1 comma 3 1 comma j becomes 1 and I becomes 3. 1 comma 3 1 comma 6 is the answer now. It's not 2 comma 6, it's 1 comma 6 is the answer. Have you got 2 comma 6? It's 1 comma 6. Look at your answer once again. See, what is 0 1? 0 1 is 2 only. But here I'm asking about I is 0, I is 1, j is 0, no? I is 1, j is 0. I is 1, j is 0. I want 1 0 value, not 0 1 value. 1 0 value. Cyprian, 1 0 value we want. Write in the paper and do it. I want not 0 1, 0 1 0 value we want. Okay? Sure. What is the output for this? All of you tell me. If the whole line we values. Yes, that also. If at all we in this particular place, if at all you interchange the values, what happens is this 4 will get replaced by 1. This 4 will get replaced by 1. Is it so? I'll do it once again. 0 1 is 2. 2 will be yes, you are correct. Yes, correct. Sorry, it's 0 1. No, correct. This 4 will be replaced by 2. Correct. In this line, so the answer is 2 comma 6. Correct. Correct. Yeah, what's the answer for this? Yes, tell me, ma. Can we store null like this? Yeah, we can store. Empty means printing nothing. If you're printing nothing means printf is 0. 0 means else part. String is not empty. String is not empty is your answer. Yeah, else part. The last one. Yeah, this is the last one. Shallow. What is the answer for this? What is the answer for this? So what am I doing here is, I'm in this particular place, what am I doing is, I'm making this as, I'm replacing n with the k, correct? Till here it is correct. Then I'm printing that also, okay, done, that is also done. Then comes, again I'm writing Kanpur as Kanpur. Is it correct? Is this particular statement correct? Is this particular statement correct? No, only this is wrong. Why it is wrong? What is str means what? str means what? str means it has the ability to store the address. In a particular address, you are storing a value. Is it correct? Can you give, in the address place, can you store the value? str means what? str means it's an address. Like 1x1. 1x1 is equal to Kanpur. Is it correct? No, it's not correct. Then how to store the data? How to store the data means you have to either use a strcpy copy statement. Copy in the location str. You copy Kanpur. This is the right statement. Or else you can blindly remember. For CSE people, you can blindly remember we cannot use equal to for equal to state equal to for assigning strings. We can't assign strings by using equal to. You have to do only string copy. This is the only way. Also write a program to copy the complete string, but you can't assign directly using assignment operator. Equal to will not work. Okay. 48. What is your question? Please repeat now. For the previous one, the answer was compile time error. The previous one answer was compile time error. If at all we do like if at all I made some changes in this. Okay. If you make a change, and now what is the answer? What your str plus 1 means what? We are in a printf statement. We are printing a string. Yes, it's ANPUR. Okay, it's ANPUR. Correct. ANPUR. Correct. Now it's correct. Okay, the answer is, what is the answer here? It is printing. After statement is done, ANPUR is your answer. Okay. Okay, here what? What are the question you have given for the C? Okay, actually I just want to copy from this place to this place, but I'm not able to. I'll try to copy the message from window to here. I copied. See, what is the answer for this? Here, what am I doing is 1, 5 array is there, 1 and 5. We are writing A star A. So here the answer is, for this the answer is value presented A. Let me say 1x1. What's the value presented 1x1? That is 1. So here the answer is 1. Okay. As you have comma here, it is even print the comma also. So I don't want to print the comma, so I remove the comma. So for this the answer is 1. After that, what we are doing? What we are doing is this one is incorrect. Why it is incorrect? Because either you have to write a bracket. Okay. This is the meaning like you are incrementing the value present at that particular place. What is the value present at A? That is 1. You are incrementing. That means this 1 will be incremented to 2. Okay. Okay. Correct. If it or else you do one thing, or else you can write this. You can remove this bracket from here, and you keep the bracket for these two. This means value presented 1x1 plus 1. That means 1x3. What's the value presented 1x3? Do we know the value presented 1x3? Do we know the value presented 1x3? Yes, we know. But this particular statement completely will be simply 5. Can I write simple 5 like that? In a line, can I write only 5 like that? Can I execute like this? I'll just remove. Can I write only 5 like this? Is it correct to write 5 only like this? Or else if you write 5, you need to assign to some other variable. You need to assign to some other variable like Q or something. You need to assign, right? If you don't, you're simply writing. Is it correct? It's not correct. No, that's the reason it's an error. If you want to correct it, you correct it by making a increment or else remove the star. Is it okay, guys? Is it okay, ma? If you do like this, what happens is we are incrementing the value, so this becomes 2 here. The answer for this particular printf statement would be 2. Okay, ma? Done. Very good. So this is about your arrays, and functions we'll discuss tomorrow. Anyways, we have we are running out of time. We have only half an hour of time. In that time, we'll try to see the automata questions, what they have asked. Okay? Chalo. We'll move to automata now. And functions MCQs we'll discuss tomorrow only. Okay. What is wrong in this? What is wrong in this? It's a syntactical error. What is wrong in this? Yeah, answer me fast. It's an automata question. Automata multiple choice has no difference, right? Yeah, it is something of same. Yeah, you remove this. Now this is okay. Okay. Okay, done. Yeah, what is the output for this? Can we write like this? Two outside, index value outside and the string inside? Yeah, we can. Strings always start with 0. 0 of 2. What is strings always start with 0. 0, 1, 2. So what is the output? Yeah, it's I, correct. Yeah. Printing the duplicate elements. Just now we have discussed the duplicate elements, right? Actually, this must not be there. I already wrote the code here. Actually, this is not there. Instead of this, you have a type your code here. Type your code here. Just see just see this program. Just see this side, other side of this. This is also being divided into two parts. No, first one. This is the actual question given. You need to do something in this. You need to fix the error in this. You need to find the duplicates. How do you find the duplicates? How do we find the duplicates? Using two loops. If a of I is equal to j, that means we have a duplicate and we are coming out of it, right? What is wrong in this, ma? What is wrong in this? They may give you this or this. What is wrong in this, both of them? Not this. What is wrong in this? This is there, no duplicate. What is wrong in this? We are checking the same element. Yeah. We should not check the same element, right? We should not check the same element, or else it will say it is duplicate, right? If at all you do like this, for every element it will say it's a duplicate, right? Yeah, it's not a duplicate. So what we have to do is, if at all I equal to j, you have to continue. If both are if we should not check the same value, we should not check the same index value. That's the reason we have written this line of code here. I added one code. We cannot change it in the automata part. They'll give you some the code which we cannot change. You have to add something over there. Okay, so this is how we do. Or else we can't change the given function. So you need to add your code. The place wherever they mention, you need to add. But you can't change their code. Okay, that's the reason this has been added. Okay, done. If I equal to j, you have to continue. That means don't check again. You just go and continue. Okay. Yeah. One more doubt I have. If at all we write continue, the continue will go to I loop or j incrementation. It will go to j incrementation or the I incrementation. Okay. Yeah. Correct. Then I have one more code over here for you. Which is a duplicate element. At which place you have a duplicate element? We are finding that also. We are printing the duplicate element. Okay. Instead of this, I prefer to go, if at all there is a change in the looping statements, we can go with that. Now delete, this point is very important. I said your array is a continuous and fixed memory location, right? Can we delete any particular element? Can we delete a particular element? If at all you want to delete, what do you do? I'll display the code also. Actually, what they do is this is the function they have given. You need to like call this function here. You need to call this function here. Okay. In order to call a function, in order to call this function over here, what is the thing we need to write? That you are supposed to write. Okay. So this is a code for deletion. We can't delete, but if at all you want to delete, what do you do? What do you do if at all you want to delete? We shift the elements. Okay, we shift the elements to the end. If at all you want to delete, you will decrement the length of an array. How do we do that? Okay, I'll tell you here. Sorry, Ma, once again, I'll go with this only. We have something called shifting in the arrays. That we'll see tomorrow because it's a very big program. That we'll see tomorrow. Okay. And here we're asking how to call a function. How do you call this function? How do you call this function? I have written code over here. If at all you're calling this function, if that particular position is not there, then it will return you 0. Then we write deletion is failed, or else the deletion is possible. Okay, this is the code for deletion. I'll explain the code first. Here we have an array of 6 elements, but we wrote only 5, and I'm trying to find 6 in this. Okay, total number of elements have been given as 5. Then I'm asking which element to be deleted. I'm asking which element to be deleted. Okay. And that many times we are shifting. That many times we are calling this position. One second. One second, ma. I'll do this. Position must be count and position must not be less than 0. Shift the elements and decrement the count. Okay, done. So what they're trying to, what is this is, oh, let me take one. I have an array here, 1, 2, 3, 4, 5. Okay. I want to delete 2 from this. Is it possible to delete 2 from this? Yeah, it's possible. What we do is, right now my length, the length of an array is equal to 5. Right now my length is 5. Okay. What I do is, I shift my elements. My array elements has to become like this. 1, 3, 4, 5. And as well, I decrement my length to 4. Now, is it appearing as if I have deleted 2 from this? Is it appearing as if I have deleted 2 from this? Yes. And I have decremented my length also? Yes. The same code has been written over here. This is for shifting, but using pointers. The count value has been decremented, the length has been decremented, and I'm shifting all the elements. I'm shifting all the elements here. Okay? Is it okay? Is it okay, ma? No? Okay, my felt. Okay, కొంచెం easy తీసుకుందాం అంత పెద్దగా ఏమవుతుందో. Okay, tell me the answer for this factorial of a given number. Factorial of a given number. What's wrong in this? Yeah, here it's float. It must be int. And if num is equal to 0, num is equal to 1, what happens to the factorial? If you multiply with 0, 0 into something is 0, right? So it must return. This is a small change in this automata. Okay, factorial of a given number. The same code they have given here it is a recursion one, right? But they have given a non-recursion way. Now, can you write a program without recursion? Can you write a program without recursion? Yeah, write down. Please write. Only one line of statement now, one for loop and one multiplication. That's it. Please write down now. Okay. Okay, then write the please complete code. Write down. Please write the complete code. Factorial of a given number. Else? Yeah, write down. Saujanya, Kumari, please write down. Saipriya, please complete the code. Wrong. Vaishnavi, please check your code once. That's it, correct. Correct, but what they have given is they have started with 0. In some case, they have started with 0. Fact is equal to fact into n. That is correct. Correct. But in some cases, what they did is they have started with 0, and they asked you what is the fault in that. 0 into something is 0, so we need to make it as 1. As well, in some cases, they made it as 0 to n only. 0 to n. So you need to make the changes. You need to make the changes in this way, and return f. Return f value. And this f. Now my question is, this f is a local variable. Where does this f have come from? Int f initially equal to 1. Return f. If at all you return f, the result will be stored into correct. It is working well, correct. Then comes the next one, 8th one. Okay, I'll just, it is becoming very clumsy. I'll just remove all these things. Again, how do we find the unique elements? Write your code, no? Write your code. How do we find the unique elements? Okay, the way which you have seen, just write in that way, no? Unique elements. All different approaches have been given. You write your approach, like using a frequency array also you can write without using 2 for loops. Find the unique elements. Are you all writing, guys? Okay, if at all you are simply watching, I'll disclose this also. You can write in your notes. Okay, these are all the different approaches. You can go with them. Okay. This was the actual question given to find the unique elements. And equal to, okay, I'm watching your code. Cycling, I'm watching your code. Oh, something is missing in your code. You have in the first for loop, in the first I loop, you wrote J as well. This duplicate is there, no? Something is there, some variable is there that has to be reinitialized. Yeah. Okay, reinitialize it to 0 again. Your code is correct, but reinitialize to 0 again and again. Two statements are missing in your code. Saujanya, C2, what happened? Write down your code. Yeah, no. Here, after the first for loop, initialize again to 0. So that for each and every element, that value will be reinitialized to 0. After the first for loop, again you reinitialize. Okay. Now the next one. Okay, ma. Only 2 people are writing. What about the other people? Please write down. No, write your code. If you simply want to see, it's okay. You can see and learn. For a single program, we can write in multiple ways. Here they are asking you the number of digits. Convert integer to string. Convert a given integer to string. If it all n value is less than 0, what does it mean? It's a negative value. So first convert it into positive value. Then number of digits functions. We are going to number of digit function. Okay. What do we do? What do we do in that? Number of digits we find. Done? Yeah. Number of digits we find. After that, here we are converting. We are making it as a string. Convert integer to string. So what do you mean by string? String means it appears to be a number, but we can't do addition, subtraction like that. Okay. So in order to make a number, for example, what I mean to say is, if 1 is there, I want to make if 1 is there, 1 has to be made to double quotes 1. That means string. Okay. How we have to make it? What is 1's ASCII value? 1's ASCII value is 49. Okay, we need to make 1 as 49. So what has to be done? Plus 48 has to be done. Yes, in order to convert that into string, what this question means is, if at all we have a number, 1, 2, 3, they wanted, if at all we do plus 2, this becomes 125, correct? But they don't want to do so. What they want to do is, I want like this, 1, 2, 3 is a string. Okay. If you do plus 2, it has to get concatenated, but it should not be like string. On strings we can't do additions, right? We can only plus acts like a concatenation in the strings, right? So that's what they want to convert. They want to convert 123 into string format. Well, how do you convert? First we find the digits. 3. 3's ASCII value is 48, 49, 50, 51. Right? 51. String ASCII value is 51. So you have to make 3 to 51. How do you make 3 as 51? Add 48. Okay, 48 means, reminder is 3. 3 plus 48 becomes 51. 51 will be stored in string of I. I is nothing but the index value. Like that, you are converting a number into a string. So what is missing in this is, they haven't given, if at all, what happens if at all you have given a negative value. Everything is correct only, but they haven't given this, what happens if at all you have a negative value. That is what they're asking. If you have a negative value, so you are going to make it as first positive, then you assign string of 0 as negative. Minus symbol has to be embedded. Okay, ma? Done. Fine. The next one is this. See, what we do is, okay, okay. These codes are a little bigger and you need to understand the complete code and write, okay? Before that, what I do is, I'll just give you few programs which you are supposed to do. These are all automata questions which have been asked recently in your other colleges, okay? Other questions are there, okay? You do these questions today. This is your homework for you. Today, this is your homework. This is reverse of a number, okay? These programs are of 2 or 3 lines. That's it. 2 or 3 lines programs are there. You just have to find answers for this. If you don't know anything, you just message me. I'll send you the answer.